Hybridization. Hybridization. Concept of hybridization. This is very important as a competition and board exam. Okay. Hybridization. Concept of hybridization. In covalent bonding, the bonds are formed by pairing of electron. Okay. In previous, we will be study about the covalent bond. In covalent bonding, the bonds are formed by pairing of electrons. Okay. If there is one unpaired electron, the electron is accepted to form one bond. If two unpaired electron, the electron is accepted to form two bonds. And it is observed that barium, boron and carbon, though they have 0, 1 and 2 unpaired electrons, they form 2, 3, 4 bonds respectively. Okay. Hence, there are 2, 3 and 4 unpaired electrons available during their combination. These are possible only when the electrons are excited from the ground state. Okay. Thus, to meet the covalent of barium to beryllium 3 and carbon 4, one of 2s electron is promoted or excited to higher energy level, and 2 p orbitals, thus the ground and line excited state configuration of barium, boron and carbon. Okay. Barium, ground state, that means this is the ground state. Okay. 2s, 0 unpaired electron, 0 unpaired electron. Okay. 0 unpaired electron. Barium, excited state, 1s, 2s, 2p, excited state. 2 unpaired electron, 2 unpaired electron. Okay. Boron, ground state, 1 unpaired electron, 1 unpaired electron. Boron, excited state, 3 unpaired electron. Carbon, ground state, 2 unpaired electron. Carbon, excited state, 4 unpaired electron. Okay. As there are 2, 3 and 4 unpaired electrons in the excited state of beryllium, boron and carbon. Beryllium, boron and carbon. Okay. As there are 2, 3 and 4. 2, 3 and 4. 2, 3 and 4 unpaired electron in the excited state of beryllium, boron and carbon. Beryllium, boron and carbon. Okay. Respectively. So they can form 2, 3 and 4 covalent bonds. So they can form 2, 3 and 4 covalent bonds. But one of the orbital is S while the other are P. So it is accepted. So it is expected that one bond will have different characteristics from the other. It is observed experimentally that both the beryllium chloride bond is BeCl2, 3 bond in BF3, BF4 bond in CH, in carbon hydrogen bond CH4 are equivalent. Okay. This shows that all the orbitals are identical in bond formation. Thus, in beryllium, S and P orbitals somehow mix and give two equivalent orbitals. In boron, one S and 2p orbitals mix. In carbon, one S and 3p orbitals mix and give 3 and 4 equivalent orbitals of the same energy. These mixed orbitals are called hybrid orbitals. The mixing of different orbitals of the same atom to give equivalent orbitals which are directed in definite direction is called hybridization. Hence, all the bond length and bond energy are alike in molecule. Okay. Definition of hybridization. Definition of hybridization. Definition of hybridization. Okay. The process of mixing different orbitals. The process of mixing different orbitals, of nearly same energy, of an atom to give same number of equivalent orbital, same number of equivalent orbital is called hybridization. Okay. The process of mixing different orbitals. Of nearly same energy of an atom to give same number of equivalent orbitals is called hybridization, or mixing of the atomic orbitals, or mixing of the atomic orbital, of different energy and formation of hybrid, of different energy, of different energy, of different energy and formation of hybrid, and formation of hybrid, and formation of hybrid orbitals of equivalent energy, hybrid orbitals of equivalent energy, is called hybridization, okay. Mixing of atomic orbitals of different energy and formation of hybrid orbitals of equivalent energy is called hybridization, or the process of mixing different orbitals of nearly same energy of an atom to give same number of equivalent orbitals is called hybridization. Okay? If two different orbitals are mixed to equivalent, if two different orbitals are mixed, if two different orbitals are mixed, two equivalent orbitals are combined, the orientation of the equivalent orbitals, the orientation of the equivalent orbitals are different. From the pure orbitals, are different from the pure orbitals. The equivalent orbitals are called hybrid orbitals. Okay. If S and P orbitals are, if F and P orbitals are called hybrid orbitals. The equivalent of orbitals are called hybrid orbital. Okay. The equivalent orbitals are called hybrid orbitals. If S and P orbitals are mixed to sp hybrid orbitals, hybrid orbitals are obtained. Hybrid orbitals are obtained. Okay. Rules for hybridization. Rules and condition for hybridization. Rule are conditions for hybridization. rules, conditions for hybridization. Okay. First point. Orbitals of nearly same energies. Orbitals of nearly same energies belonging to the same atom or ion can undergo hybridization. Okay, first rule, hybridization. Orbitals of nearly same energy belonging to same atoms or ion can undergo hybridization. Okay, second rule. First rule, orbitals of nearly same energies belonging to the same atom or ion can undergo hybridization. Second point. Number of hybrid orbitals produced is equal to the number of orbitals produced is equal to the number of orbitals taking part in hybridization. Okay. Number of hybrid orbitals produced is equal to the number of orbitals taking part in hybridization. Okay. Third position. Most of the hybrid orbitals are equivalent but not necessarily identical in shape. Okay. They differ in orientation in space. They differ in orientation in space. Okay. Fourth point. An orbitals undergoes in hybridization and not the electrons. An orbitals undergoes in hybridization undergoes in hybridization and not the electrons. Okay. Fifth point. Hybrid orbitals from stronger bond. Hybrid orbitals from stronger bond than the bond formed by single unhybridized orbitals of comparable energy. Orbitals of comparable energy. Okay. Hybrid orbitals from stronger bond than the bond formed by single unhybridized orbitals of comparable energy. 6 point. The electron waves present in hybrid orbitals. The electron waves present in hybrid orbitals repel each other, okay, due to which they lie far apart. Okay. 7. Hybridization determines the geometry. Hybridization determines the geometry, shape and structure. Okay. Structure of the molecule, including bond angle, okay. This is total rule for hybridization or conditions, okay. Types of hybridization.